If you own an air source heat pump, there are settings on your controller that can affect your comfort, your hot water, and how much electricity your system uses. However, not every setting can be changed, especially not by you. For example, your heating curve, your backup heater settings, your hot water hygiene program. And if you've searched online for the best heat pump settings, you've probably seen people giving very precise numbers. Like, set this to 50 degrees Celsius, change this curve to 0.4, move this setting to -5. The problem is that there is no single set of perfect numbers for every air source heat pump. A Valent Aerotherm Plus, Mitsubishi EcoDan, and Daikin Altherma can use different controllers, different terminology, and different control strategies. Even two houses with the same heat pump may require different settings. In this video, we will focus on what 10 important settings you need to know. We'll divide them into 3 groups. Green, everyday homeowner controls. Amber, controls you can use but should understand first. Red, commissioning settings you should understand but generally shouldn't alter without following the manufacturer's instructions or speaking to your installer. And once you understand those 3 groups, your heat pump controller becomes much less intimidating. 20 degrees Celsius room temperature, 50 degrees Celsius hot water temperature, 40 degrees Celsius heating water temperature. Those numbers don't mean the same thing. The room temperature target is how warm you want the home. The domestic hot water target relates to stored water for showers and taps. And the heating flow temperature is the temperature of water being sent through the space heating circuit. Mix those up and the controls become confusing very quickly. So let's start with the simplest one. Setting 1, room temperature target. Imagine your controller says 19 degrees Celsius. You feel cold, so you turn it up to 23 degrees Celsius. What you're telling the heat pump is, come on, work harder. Think of it as a destination rather than an accelerator. If you want the house at 20 degrees Celsius, setting the target to 23 degrees Celsius mean my new target is 23 degrees Celsius. This is particularly important with air source heat pumps because the overall heating system is normally designed around maintaining comfort rather than producing a sudden blast of heat. So what temperature should you choose? There isn't one correct answer. 19 degrees Celsius might be perfectly comfortable for one household. Another might prefer 20 degrees Celsius or 21 degrees Celsius. Your age, activity level, clothing, building and personal comfort all matter. The important thing is to choose the temperature you genuinely want, rather than repeatedly turning the target up and down to control how quickly the heating responds. Setting 2, heating schedule. For years, many of us have programmed boilers something like this: heating on at 6 a.m, off at 8 a.m, back on at 5 p.m, off again at 10 p.m. Unfortunately, you cannot copy exactly the same schedule for heat pump. On many modern heat pump controllers, you're really programming when you want different room temperature targets. For example, you might have a normal comfort period and a reduced temperature period. Different manufacturers describe this differently. You might see comfort, eco, reduced, setback, or simply different scheduled room temperatures. What you're telling the system is, at this time of day, this is the indoor temperature I want. Setting 3, holiday or absence mode. Now imagine you're leaving home for 10 days in January. You don't need the house maintained exactly as though you're sitting in the living room, but switching the entire system off without understanding what that does isn't necessarily the answer either. This is why many controllers provide something called holiday mode, away mode, or absence mode. The name varies, and importantly, what the function does also varies, like reducing the normal space heating operation. It may allow you to enter a return date or maintain frost protection functions. So, before you travel, find the function in your manufacturer's manual and establish exactly what it changes. Setting 4, setback temperature. Let's say your normal room target is 20 degrees Celsius. At night, you don't necessarily want the same temperature, so your controller allows a lower target. That's a setback. For example, you might have 20 degrees Celsius during occupied periods and 18 degrees Celsius during a reduced temperature period, whatever number works for your house. The setback determines how far you're allowing indoor temperature to fall before the next comfort period. A larger setback may mean less heating during the reduced period, but it can also mean more temperature recovery later. Start with your manufacturer's guidance and observe how your house actually behaves. Setting 5. Domestic hot water temperature. Now look at another temperature on the controller. You might see DHW temperature. DHW means domestic hot water. This is the water associated with your shower, bath, and hot taps. It is not your room temperature, and it is not the same thing as your space heating flow temperature. Now imagine your stored hot water is hotter than your household really needs. You use the shower and mix a substantial amount of cold water into it. You might reasonably wonder, why am I heating the cylinder hotter than necessary? That's because producing higher temperature hot water generally creates more demanding operating conditions for a heat pump. But don't immediately conclude lower is always better. There is a trade-off. A hotter cylinder contains more usable stored heat. At your shower, that hot water is mixed with cold water to produce the temperature you use. If you significantly lower the stored water temperature, the same cylinder may provide less usable mixed hot water before it needs reheating. So you are balancing heat pump efficiency against available hot water capacity and household demand. That's why you may hear figures around 50 degrees Celsius discussed for some heat pump systems. But you shouldn't treat 50 degrees Celsius as a universal setting for every cylinder and every installation. Follow the requirements for your particular heat pump, cylinder, and hot water system. And there's another reason for that caution, which will be discussed later in this video. Setting 6. Domestic hot water schedule. Suppose your controller currently heats your domestic hot water early in the morning. You read that an air source heat pump may operate more efficiently when outdoor air is warmer. So you think, I'll move the hot water heating to the afternoon. That may make sense. But then you discover your electricity tariff is much cheaper overnight. Now which is better? Efficiency and cost are not the same thing. Your heat pump might achieve better efficiency under warmer outdoor conditions, but if electricity is considerably cheaper during another period, that period could still cost you less overall. Setting 7. Hot water boost. Here's the situation. Your normal hot water program works perfectly most days. Then a change in the number of occupants and the cylinder doesn't have enough usable hot water. For this situation, many heat pump controls provide some form of DHW, boost hot water, boost or one-off reheat. It tells the system that you need additional hot water outside the normal program. Using it every day suggests your normal DHW setup isn't matching your normal demand. So think of boost as an exception button. So far, we've been telling the system what we want. Now we start entering settings that can determine how the system delivers those things. Setting 8. Heating curve or weather compensation. This is one of the most important controls on many UK air source heat pump installations. You may see it described as heating curve, weather compensation, weather-dependent control, or another manufacturer-specific term. The names differ, but let's understand the basic idea. Your house loses heat to the outside. When it's very cold outdoors, that heat loss generally increases. When the weather becomes milder, the amount of heat the house needs falls. A weather-compensated heating system uses outdoor conditions to adjust the heating water temperature accordingly. So imagine this simple example. When it's very cold outside, the system may need warmer water going through the heating circuit. When it's mild outside, it may be able to use cooler water. So there is no universal UK heating curve number. Your installer should establish the appropriate control strategy during commissioning. What you should learn is how to recognize the symptoms that it may need reviewing. For example, does the house consistently become too warm during mild weather? Does it consistently struggle as outdoor temperatures fall? Has the behavior changed after major insulation improvements? adjustments. If you have worries about this, you can tell your installer. The house reaches target temperature when it's cold outside, but consistently overshoots in milder weather. Could we check the weather compensation settings? Setting 9. Legionella/hot water disinfection program. If your system stores domestic hot water, it needs an appropriate strategy for controlling the risk associated with Legionella bacteria. Depending on the hot water system, you may see something called Legionella protection, disinfection, thermal disinfection, or another similar term. Some systems periodically raise stored water temperature above the normal DHW target as part of that strategy. Depending on the heat pump and cylinder arrangement, supplementary electrical heating may be involved. But here's the critical point. Not every air source heat pump hot water system handles this in the same way. So if you notice your system occasionally using more electricity during hot water production, don't simply find a disinfection setting and switch it off. This isn't just an energy-saving control. Understand it. Don't casually disable it. Setting 10. Auxiliary or backup heating. Your air source heat pump installation may have supplementary heating available. Depending on the system, this could include direct electric heating. You might see terms such as backup heater, auxiliary heater, booster heater, and in more advanced controls, bivalent point or equilibrium temperature. The system design and control method determine whether and when supplementary heat is allowed or required. Now imagine you discover that direct electric backup heating has operated. Ask your installer, at what conditions is my auxiliary heater supposed to operate? Why was it configured that way? How often would you normally expect it to operate in this installation? And if it's operating frequently, is that consistent with the system design? Why the brand matters. At this point, you might be wondering why I haven't simply shown you exactly where every one of these settings appears on your controller. There isn't one universal UK air source heat pump controller. A function that one manufacturer calls heating curve may be presented differently by another, and differences can exist between products from the same manufacturer. Deduct settings are not the best settings. A default is a starting configuration. Your installer commissioned the system as per the applicable manufacturer's requirements and system design. Your 3 levels of control. Let's make everything we've learned incredibly simple. These are normal homeowner controls: room temperature target, heating schedule, holiday or absence mode. You're telling the system what you want. These include setback temperature, domestic hot water temperature, DHW schedule, hot water boost. These can affect comfort, hot water availability and cost. You may use them but understand the trade-off. These include heating curve/weather compensation configuration, Legionella or hot water hygiene program, auxiliary/backup heating configuration. These relate more closely to how the installation has been commissioned. You should understand them. MCS's current heat pump commissioning documentation includes the setup of controls and whether the controls were demonstrated and explained to the customer. So if your system was installed under MCS and you were left with a controller you don't understand, go back to the installer, ask the questions. In the next episode, we're going to discuss why your electricity bill increased since installing a heat pump. If you're following these Heat Pump Basics series, please subscribe to the channel. Thanks for watching, and I'll see you in the next video.